This is day 14 of Unit 9. We started today with a short quiz, so if you missed class, you'll need to make that up. And then after that, we began working on some of the problems on pages 11 through 14 together. So we'll do that here together in the video. So we started with problem number 3 on page 13 in your packet, so take a moment and look at that. So 5 teens go to a movie. They want to sit together in a row with one of them in each aisle seat. Each row is 5 seats wide, including 2 aisle seats. So part A is pretty straightforward, like problems we've been doing. There's a couple ways you could do that. So all you're trying to figure out in A is just seating them in a row. The order does matter here. Because putting them in a row, so and you can't repeat, so that's a permutation. 5p5 would be one way to do it, or you could just do a decision chart, 5, 4, 3, 2, 1, or you could do 5 factorial. Any and all of those will get you the correct answer, which is 120. Now, B and C get a little more complicated, and remember that when we have repetition, I said to use a decision chart. Same thing with problems where there's a restriction or something that can't happen or has to happen. There you're going to have to use a decision chart. Those are not just straightforward permutation or combination formulas. So B and C would qualify as restrictions. So if Chris wants to sit in an aisle seat, how many ways can they all sit in a row? So there's particulars. Chris has to sit in an aisle seat, which is what makes it a restriction. So when there's a problem like that, again, you're going to do a decision chart and always start in the chart with where the restriction or the specific thing is happening. So in this case, the specific thing that's happening is Chris and having to sit in an aisle seat. So we'll start with him in the decision chart. So the first blank is going to represent the number of choices for Chris. So the number of choices for Chris is going to be 2 because there's 2 aisle seats. And then after Chris is seated, the rest don't matter. So there's 4 left, then 3 left, then 2 left, then 1 left. Okay, so that gives us 48. Okay, so hopefully now that helps this problem make a little more sense. So if I were you, I would pause the video for a moment and try part C and then play to check your answer to see if you've done it correctly. That's kind of what we did in class. I gave a moment for students to try it and then we went over it. So I'd probably pause the video here and try part C. Okay, so if Patrice wants to sit in an aisle seat with Beth next to her, how many ways can the 5 students sit? Well, we're going to seat Patrice first, since Patrice is the one with the specifics. So there's 2 aisle seats, so Patrice has 2 choices. Now, hopefully you did this correctly and you thought about this correctly. Patrice has already been seated. So even though Beth wants to sit beside Patrice, and yes, there are two different seats here that are beside the aisle seats, Beth does not have 2 choices because Patrice already picked. She had 2 choices, but once she's sitting, then Beth only has 1 choice. Okay, so you have to really kind of think about that, not 2. Common mistakes to say 2 there. And like I said, while I agree there are 2 seats beside the aisle seats, Patrice picks first, sits down, and then Beth has to sit beside her, so that's only 1 choice. And then 3, 2, 1. And when we multiply that, we get 12. Okay. The next one we looked at was on page 14. We had already done page 13, number 4 in a different video. So page 14 was next, and that was the pyramid problem. So once again, I'm seeing there's a restriction here. The words cannot end with D, so that's not a straightforward permutation problem. That is a decision chart. And I'm going to start in the chart with the part where the restriction is, which is the end. So I'm going to start here on the end. Again, you might want to take a moment, pause the video now and try this, and then play to check your answers. So hopefully you paused that and you tried. There would be 6 choices because I can't end with a D. Now I'm going to come to the front, and I've just used a letter, so there's 6, 5, 4, 3, 2, 1. So 6 factorial times 6 gives us our answer, which is 4,320. Okay, next we moved on to problem number 6, which is on page 14. So this was the problem, and these problems were originally in a textbook that we used to use, but this was the original problem. So first, just take a look at that. Your teacher's giving you a list of 10 questions to study for a test. Told you the test would consist of 6 questions from the list. You realize you do not have time to study all of them, so you only studied 7. Your teacher randomly chose 6 questions to put on the test. So first, just make sure you understand what's happening. There's 10 questions total on a list. 6 are being put on the test, and you only studied 7 of them. So we're going to figure out how many options of 4 questions can the teacher pick from the 7 questions I studied. Well, first of all, this is just one possibility. We're trying to figure out all the number of ways that the teacher could pick questions for the test. So one option would be the teacher could pick 4 from the 7 that you studied. Well, hopefully you're realizing the order doesn't matter here and that we can't repeat questions. So this is a combination. So that first, there's blanks there. That first blank would be 7C4. Why? Because you studied 7 and the teacher's picking 4 from the 7 that you studied. Okay, now, if that's the case, and again, this is just one option, you could have studied 4. If the teacher's picking 6 total, and this represents the teacher's picking 4 that you studied, that means there's 2 left that the teacher's going to pick, because remember, these 2 numbers have to total 6, because that's the numbers on the end, the R's, are representing what the teacher's picking. So 4 and 2 make 6, which is what the teacher's picking. The first numbers, the ends, have to total 10 because there's 10 total questions that we're picking from. So that means this has to be 3. So let's just make sure we understand what these represent. The 7C4 represents the teacher's picking 4 questions from the 7 that you studied. This 3C2 means the teacher's picking 2 questions from the 3 that you did not study, which means that we're picking total 6 questions, and we're picking from a total of 10 questions. Okay, so that takes care of part A. Now, B says, to find the number of tests the teacher might have constructed, what should you do with these results? So in other words, this is the 4 that they're picking from the ones you did study, and the 2 that the teacher's picking from the 3 you didn't study. And this is an and. She's picking both. So and means that we should multiply. So there, I was just looking for you to say multiply. Okay, now, in how many ways could your teacher have randomly selected 6 of the 10 questions? Express this in combination notation. So in other words, we're just looking for a total here. The total was 10 questions, and the teacher is picking 6. So 10C6 would be what we're looking for there, which if you do that in the calculator is 210. By the way, I did explain today how to type the combinations and permutations in the calculator. So if you we're not in class, have a friend show you, or come and see me and I can show you how to input 10C6 into your calculator. So now we're on to part D. And D, E, and F are kind of interesting because they're combining combinations with what we did in the first half of the unit, which is probability. So if you recall, probability is what we're looking for over the total. So of these that we just did here, A, B, and C, which one represents the total? Well, that would be C, 10C6. So total for probability is the denominator. So I know for each one of these, D, E, and F, I'm going to put 10C6 in the denominator. Okay, so now I just have to figure out what would go in the numerator. Well, if I was looking for, and D, we're not doing this, but I'm just giving this as an example. If I was looking for the probability that the teacher was going to pick 4 from the 7 you studied and 2 from the 3 you didn't study, then I would put this 7C4 times 3C2 over 10C6. Okay, it didn't ask for that, but again, we were just kind of setting this up. So that would be the probability the teacher picked 4 from the 7 that you studied. Okay, so now on D, we're looking for what's the probability that your teacher picked 6 of the selected questions. Well, she's picking from the 7 you studied, and it's saying what's probably you will have studied 6 of the selected questions. So I'm studying 6, or she's picking 6 of the 7 that I studied. And remember, she's only picking 6. So if she picks 6 from the 7 you studied, then from the 3 that you didn't study, she's picking none. Okay? Hopefully that makes sense. So 7C6, I'm going to do that in the calculator. That's 7. And anytime you're choosing 0, I don't know why that's doing that. Anytime you're choosing 0, there's only one way to do that. So that's 7 times 1 over 210. So that gives me 7 over 210, which simplifies to 1/30. Okay, so I'd like you to pause the video a moment, try E and F using the same approach, and then play to check your answers. Okay, so what's the probability you will have studied 5? Well, that would be 7C5. Of the 7 I studied, 5 were picked, which means of the 3 I didn't study, remember 6 total are being picked, so that means only 1 would be picked from the 3 I didn't study, over the total 10C6, which is 21 times 3 over 210. That looks like 21.3. Let's put that in parentheses, which is 63 over 210, which simplifies to 3/10. And F, what's the probability you will have studied 3 of the selected questions? Well, from the 7 I studied, 3 are picked. And from the 3 I didn't study, remember this has a total 6, so that has to be 3 were picked over the total 10C6. Well, that equals 35 times, there's only one way for me to pick 3 from 3 over 210. So that's 35 over 210, which simplifies to 1/6. Okay, we will be doing a few problems in the future like this, where we're combining combinations with probability. So if you have questions on that, please see me to help explain how we would do problems like this. Okay, now the next thing, that was pretty much our time for class because we did have shortened periods, but I did tell students that for homework I want you to do pages 11 and 12 because that's what we didn't get to. We got to everything on 13 and 14. So for 11 and 12, specifically the ice cream problem, ice cream shop that starts on page 11, you need to know, because it's not listed there on the paper, you need to know that this ice cream shop offers 5 different flavors of ice cream. Okay, so just write that down somewhere, that there are 5 different flavors of ice cream that you're choosing from. And then to answer the questions, the situations, just read the situations carefully. Read situation 1, 2, and 3, and then you're using 5 flavors. Situation 4, you have to read very carefully, and there are sub-problems. So you're going to read each sub-problem and answer them before answering the whole entire situation 4. So read that carefully, try that on your own for homework, pages 11 and 12. And so again, we did 13 and 14, so all you have to do would be 11 and 12 for tomorrow. Keep in mind you have a quiz coming up next week.